Good day, everyone. This presentation is all about data structures and algorithm. Our chosen topic is topological sort. Topological sort is a linear ordering of its vertices such that for every directed edge, A, B from vertex A to vertex B, A becomes before vertex B in the ordering. Meaning, it is a concept in graph theory and algorithm that respects the partial ordering imposed by the directed edges of the graph. Topological sorting is a fundamental algorithmic technique used to establish a linear ordering of vertices in a directed acyclic graph or DAG respecting the dependencies between them.
Graph should be direct and acyclic. Yun ang pinaka-condition ng topological sort. DAG meaning direct and acyclic graph. Kung ang graph natin ay indirect, hindi natin mahanap ang topological sorting. Kung ang graph naman ay direct, pero nagko-contain ng cycle na katulad nito. 1 to 2, 2 to 3, and 3 to 1. Yun ang cycle natin ay mali na. So kung ang graph ay may cycle, hindi na posible na mahanap natin ang yung topological ordering ng graph. So dapat ang graph ay hindi nagko-contain ng kahit na anong cycle.
This is the algorithm of topological sort. The node can have any incoming directed edges. It must have an degree of 0. Imagine meron tayong graph, which is a collection of node connected by directed edges. Bawat node ay nagrepresent ng something, like a person or a concept. At ang edges naman ay relationships or connection sa mga nodes. Now, in this algorithm, gusto nating i-check kung ang specific node sa graph ay may incoming directed edges. In other words, gusto nating hanapin kung meron bang mga edges na nagpo-point papunta sa node na iyon. In graph terms, in degree of the node is the number of incoming edges. In this case, check natin kung ang degree niya ay 0, meaning there are no incoming edges. Number 2, we'll find a node with an degree of 0 and add it to the topological ordering. Simulan natin sa paghahanap ng node sa graph na walang incoming directed edges. Sa madaling salita, naghahanap tayo ng node na hindi dumidepende sa kahit anong node. Number 3, once a node is added to topological ordering, we can take the node and its outgoing out of the graph. Pagkatapos nating mahanap yung node na walang directed edges, lalagay natin yung topological ordering dahil wala siyang dependencies. Bali itong node na ito ang starting point natin. Pagkatapos nating mailagay ang node sa topological ordering, alisin din natin sa graph kasama yung mga outgoing edges. Therefore, repeat this process. Look for any node. When any degree of 0, add it to the ordering. Ulitin lang natin yung step 1 to 3 hanggang sa wala nang matirang node sa graph.
Implementation. Identify a node with no incoming edges. It is a key step in topological sorting because it allows us to find a starting point for the sort and gradually build the linear order by removing nodes and their outgoing edges from the graph. Add the node to the ordering. It refers to the process of including a node in the final sorted order. Remove it from the graph. It is often a conceptual step and does not necessarily involve physically deleting the vertex and edges from the graph data structures. It primarily means that you consider the vertex as visited or processed, and it is no longer part of the ongoing search for vertices with no incoming edges. Lastly, repeat all three steps. We'll keep looping until there aren't any more nodes within degree 0. This could happen for two reasons. One, there are no nodes left. We've taken all of them out of the graph and added them to the topological ordering. Two, There are some nodes left, but they all have incoming edges. This means the graph has a cycle and no topological ordering exists.
Ngayon, i-discuss natin kung paano gawin ang method ng topological sorting. This is a directed acyclic graph. This is directed dahil every edges niya ay merong mga direksyon. Meron ba tayong nakikitang kahit na anong cycle? Wala. So, ang topological sorting dito sa graph na ito ay posible. Paano natin gagawin ang topological sorting dito? Ang first step is find out the in-degree of 0 of each vertex in the directed graph. Mayroon tayong concept sa graph na tinatawag na in-degree at out-degree. In-degree meaning yung number ng edges na papunta sa vertex. Out-degree naman is yung number ng edges na palabas sa vertex. Okay. Ngayon, ang kailangan nating hanapin is yung in degree of 0. Dito sa 1, meron bang mga edges na papunta sa 1? Wala. Meron lang mga palabas na edges, so ang in degree ng 1 ay 0. Next is 2. Merong isang edge na papunta sa kanya, which is yung 1 to 2. So ang in degree niya is 1. Next, 4. In degree ni 4, meron dalawang edges na papunta sa kanya, 2 to 4 at 1 to 4. So, ang in degree niya is 2. Then 5. In degree ni 5, 1. Last is si 3. In degree ni 3 is 2. Since nakuha na natin yung mga in degree of every vertex, sisimulan naman natin ngayon yung second step. Kukunin natin at ilalagay sa topological ordering yung mga vertex na may in degree of 0 para masabi natin siyang linear ordering. Now, find out which vertex is having in degree of 0. Si 1. So, ilalagay na natin siya sa topological ordering. Ang susunod naman na step, from this graph, we will delete 1 and all the edges which are outgoing from this vertex. Ilan ang edges ni 1? 2. So, i-delete natin siya. Pagkatapos nating i-delete yung mga edges, mapapalitan ngayon yung mga in degree ng mga natitirang vertex sa graph. So, the graph would be something like this. 2, 4, 3, and 5. I-update natin ngayon yung mga in degree ng mga vertices. In degree of 2 is now 0. Kanina, meron siyang 1. At dahil nga dinilit natin yung outgoing edges ni 1, minus 1 natin yung in degree ni 2. 1 minus 1 is equal to 0. Next, si 4. Ang in degree ni 4 ngayon ay 1. Dahil na-delete din yung edge. Then, si 5, still 1. Last, si 3, still in degree of 2. Ngayon, uulitin natin yung ginawa natin kanina. Hanapin yung vertex na may in degree of 0, which is si number 2. Same step pa din ilagay natin siya sa topological ordering at i-delete yung mga outgoing edges. Kada may madidelete tayong vertex sa graph, magbabago yung mga in degree value nila. Ang graph natin ay magbabago ulit na merong 4, 5, and 3. Next, update natin mga in degrees nila 0, 1, and 1. Then, lagay ulit natin sa topological ordering. Tapos, i-delete natin. Now, our graph would be, we have only 3 and 5. Dinilit natin yung edges ni 4 kanina. May edges pa ba tayo between 3 and 5? Wala na. So, ang in degree nilang pareho is 0. Sa instance na to, may dalawa tayong in degree of 0 which is 3 and 5. Ang gagawin natin, pwede tayong mamili sa kanila kung sino ang gusto nating ilagay sa topological ordering. Pwede si 3 or si 5. For example, kinuha natin si 3. Now that 3 has been deleted in the graph, we can now also take 5. At ayan, nakuha na natin ngayon yung topological ordering sa graph natin. At ang posibleng ordering ng graph na to is 1, 2, 4, 5, and 3.
Next is the sample of no valid topological orderings. So suppose example, we have this kind of graph. Now, i-find out natin topological ordering of this graph. So, hindi natin mahanap ang topological ordering sa graph na ito. So, why? Dahil meron isang directed cycle. So, kagaya ng mga discuss natin kanina, pag may mga cycle ang graph, hindi natin mahanap ang topological ordering. So, let us see kung possible ba na masolve natin ito. So, same step lang. Find out in degree of every vertex in B0, in degree of E0, in degree of B2, kasi dalawa yung edges na papunta sa B, in degree of C2, at in degree of A1. Ngayon, pili tayo ng vertex na may in degree of 0. We can select D or E. Suppose we are selecting case 1. So after choosing vertex E, delete this vertex. Now, the graph would be A, B, C, and E. In degree of E, same lang nung nasa figure 1, 0. In degree of C2, B1, and A1. Burahin ulit natin ang may in degree of 0, which is vertex E, kasama ang edge. Now, the graph would be A, B, and C. Ilagay ulit natin mga in degree of every vertex. We have 1, 1, and still 1. Meron pa bang in degree of 0? So, wala na. Lahat ng vertex ay may in degree of 1, so we cannot proceed further. Kaya kung ang graph ay mayroong cycle, then it is not possible to find out topological ordering of the graph.